Let us circle and we observe clearly, because some of us are not getting the difference. This one, let us come to 5 and we see whether there is a number that can divide 5 exactly. Which number can divide 5 exactly without giving a remainder? Can 2 divide 5 without giving a remainder? 5 divided by 2, 2 remainder 1. Good, there is a remainder. So 2 cannot go into 5 exactly. What about 3? Still 3 cannot go. 3 is not a factor of 5. 5 has only 2 factors, 1 and itself. Therefore, this one is prime. Good. We come to 6. Which number can divide 6? 3 can divide 6. 2 can divide 6. 6 divided by 3, 2 without a remainder. 6 divided by 2, 3 without a remainder. Since there are very many numbers that can divide 6, 6 is not prime. Come to 7. Which number can divide 7? No number can divide 7 exactly, apart from 7 itself. Yes, therefore, this one is prime. Now, is there any number that can divide 8 exactly? Yes, 4 can divide 8, 2 can divide 8. This one is not prime. Come to 9. Is there any number that can divide 9? Yes, 3. Good. 3 times 3, 9. Meaning, 9 divided by 3, 3 exactly, no remainder. So, this one is not prime. Which number can enter 10 exactly? Now you are picking 5 and 2 can enter 10. Since 10 has numbers that can go into it exactly, this 10 is not prime. Come to 11 class. Now you are picking up. 11. Which number can divide 11? No number can divide 11. Good. Apart from 11 itself. Therefore, 11 has become a prime number. 12. Which numbers can break down this 12? Yes, Namkasa? 3. Good. Because 12 divided by 3, 4. Another number, even 4 can break. Yes, Tom, 6 can break. This one is out. This one is out. Is not prime. 13. Which number can divide 13? No number. Apart from 13 itself. Good. Apart from that, therefore 13 is a prime number. 14, 7 can go. Therefore is not prime. 15, 5 and 3 can enter 15. Meaning 15 is not prime. 15, 9 are not prime numbers. But they are odd numbers. We come to number 16. Which digit can enter the 8 and 4 plus 2? Good. So this one is not prime. Is not prime. We eliminate it. 17. Which number can go into 17 exactly without a remainder? Think. 2. No. 2 will give a remainder. 3. No number can go. Good. So let us consider it to be prime. No number can go into 8. Come to 18. 18. Which numbers can break down 18? 9. Good. Because 9 times 2 you get 18. Meaning 18 divided by 2, 9. 18 divided by 9, 2. 2 and 9 can enter 18 exactly. And this one is not prime. Come to 19. Which number can break 19? No number. Yes, apart from 19 itself. Good. So we are taking this one as prime. Come to 20. Very many of them. 2, 5, 10, 4. All of them. So this one is not prime. It has very many numbers that can go into it. You come to number 21. Is it a prime number? Which number can enter 21? 7. Yes, because 7 times 3, you get 21, which implies 21 divided by 3, 7. Exactly. 21 divided by 7, 3. Therefore, 21 has more numbers that can enter into it. It has numbers that can divide it. Therefore, it is not prime. There is no number that can divide a prime number exactly, apart from the number itself. And it goes there once. Once it goes there once, we have got two factors, 1 and itself. You come to 22. Very many, even an even number, 22. 11 can go, 2 can go, so it is not prime. Having very many numbers that can go into it. Come to 23. Come 23. Is there a number that can go into 23? Can 3 go into 23? Let us see. We learned divisibility test. We said a number is divisible by 3 if the sum of the digits in it is a multiple of 3. Let us get the sum of the digits and we see whether they will give a multiple of 3. 2 plus 3, 5. And 5 is not a multiple of 3. Therefore, this number is not divisible by 3. No number can divide it apart from itself. This one is prime, only that it is left out, because they are telling us less than 23. Prime numbers less than 23. Because we are saying less than 23, we are not going to include this 23. What are you looking at? We are looking at listing elements of a described set. They have described set K are prime numbers less than 23. Then show those prime numbers that are less than 23. Yes. So have we skipped any number there? Because we want to show all the numbers less than. Let's prove this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Then we are going to pick the prime numbers from all of those ones, because they are only needing prime numbers. Prime numbers. So where we have put P and a circle are our prime numbers. So can you write? So we are going to say set K equal to, open the curly brackets, begin with 2, then 3 and 5, come to 7, leave 8, 9, 10. They have very many numbers that can divide them. Then you bring 11, come to 13. 15 is not a prime number, but it is just odd number. 16 leave 17, come to 19, 20 leave 21, 22, and we don't include this because they said less than. It is a prime number, but we are told less than 23. Close the curly bracket. Do not forget to separate them using the comma. So we have written down numbers of set K. Remember, we are looking at listing elements of a described set. They have described the set K as prime numbers less than 23. So these are the prime numbers less than 23. If you look at all of these numbers, no number can divide them apart from themselves, making them having having two factors, 1 and itself. Which is the first prime number? 2. The first prime number is 2. So when they tell you write it down, prime numbers less than 2, it is not there. The set will be empty. Prime numbers less than 2, your set will just be like this, nothing there. This is what we call that is what we call an empty set. Should the question be prime numbers less than 2, because the first prime number is 2. Less than 2, there is no prime number there. 1 is not a prime number, because prime number should be with 2 factors, 1 and itself. But now this is 1 and itself, again it is a 1. So So they have described set K and we have written members of set K. Yes, now come to number 6. Number 6. Set L equal to common factors. Common factors. Common meaning the factors you find in 12, the same factors you are finding in 18, the similar factors. So we shall get factors of 12, common factors of 12 and 18. And again, we get factors of 18. We observe. The common factors. Which factors are you seeing in factors of 12? And again, you are seeing them in factors of 18. Remember, in primary 4, also primary 5, we learned how to find factors of numbers. Therefore, we are going to find factors of 12, then we find factors of 18, using the very knowledge we used in primary 5. So, list members of set L. Set L is going to contain common factors. Not all factors, but only the common ones. However, we are going to first get all of the factors, then we observe what are the common ones, which ones are similar. We begin. How did you find factors of 12 in primary 5? Yes, so we wrote factors of 12. Tell me, how did we do? Okay, you use the multiplication. How? 1, yes, times 1 times 12 itself. 1 times, okay, let me see what we shall put here to get this 12. What do you put here to get 12? Because all of these answers here are going to be 12. 1 times, which digit is here to get 12? Good, it is 12 itself.